Hello everyone, I am Rekha Murthy, Assistant Professor from Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology. Today I am here to discuss about the problem based on the Hopkinson's test. The problem is the following results were obtained during a Hopkinson's test on two similar 230 volt machines. Armature currents 37 ampere and 30 ampere. Field currents are 0.85 ampere and 0.8 amps. Calculate the efficiencies of a machine if each has armature resistance of 0.33 ohm. Okay, so they have given the values, the given data. As this is the Hopkinson's test, right? And supply voltage is 230 volts. And the armature currents. See, usually this is a Hopkinson's test, means you have to think about the motor generator setup. So they have not mentioned which armature current is this. So by default you have to think that the first current which they have given, it is a motor armature current. This is a generator armature current. So motor armature current IAM 37 ampere and the IAG is 30 amps. Then field currents. Okay, again for this also the first value of this current will be your motor, and the second value will be with respect to the generator. So the shunt field currents of the motor, it is 0.85, and for generator it is 0.8 amps. Calculate the efficiencies of a machine if each of the has a armature resistance. So they have given also the armature resistance as 0.33 ohms. Okay, so these are the given parameters. Now let us draw the circuit diagram. So as we know, I can draw this circuit diagram. I can draw that motor first. Okay, and this has been coupled to the generator. Okay, so I'm going to close this switch here behind like this, and here I'm going to write down the field winding. Okay, here this will be the respective field winding of the motor. Okay, then this, as usual, there was a switch during a theory we were discussing, no? So I am going to close that path directly. Okay, so here this will be the line current which will enter through here, and this is the voltage, that is 230 volts. Okay, now let us mark the currents, the indication of current, that is what it is given here, IAM, armature current. See, the motor, it will take an input as a electrical input. So therefore, the current direction will be inward. Okay. And what about the generator? The current, it will gives out. It will generate the electricity, right? So this is how the current will come here. And the current obviously to the field winding, it will always enter here, also always enter. Okay, so like that you have to mark the direction of the current value. So here you can write down what value it is flowing. This is the value is 37 ampere. Okay, and the current for this is 30 ampere, right? And here this current will gives out, and the current which will enter here, it will be like this, and finally you will find this full loop, it will be completing like this. Okay, okay, so fine, this current will be entering here, the line current, the main current. Okay, so this is how you can mark the complete direction of the currents. Okay, Now this is what current it is? Field current, right, of motor. It is around 0.85 and this current is 0.8. Okay. So here you have to be very thorough with the KCL so that you can find out this value of current, this value of current, and here this as well as this current. Okay, so consider this node. Consider this node. So what will be the value of this current? You have to find out what is the value of this current. How you can determine? See here, you can see that what is to this node, what is the current which is leaving out, that is 37, and the another current is 0.85. Okay, the incoming current is entering to this. Okay, let me take this current is X, Ix. Okay, so this is incoming current to this node, so it is positive, and these two current are leaving out, so it will be considered as a negative, right? So therefore here I can these two currents are leaving out, so I can take a sum of these two current which is going outward, so I can take it as sum of those two currents, so it will be around 37.85. So this current value is 37.85. Okay. Now similarly let me take this node, consider this generator, this node, and find out this current Iy. Okay. So here what is the direction I am getting? Here the current, this current is entering to this, so it is positive, and this current is leaving outward, so it is considered as negative. So what will be the answer here? We will get around 29.2. So that value you have to mark it here. So I can mark here this current value is 29.2 amps. Okay, this current value is 29.2 amperes. Then after that you consider this node also. Okay, so here also again you can determine this current. So what can be that current value? You can see that let me take Iz, X, Y, Z over no. So I'll take Iz. So here you can observe at this node this current is leaving, so I can take minus 37.85, and this current is entering, so plus 29.2. So finally the difference of these two current. Okay, so what is the value you will get? You will get around 8.65. 8.65. Okay, so this answer will be 8.65 amps. So that will be the value of the line current. So this is how you have to be thorough with the KCL so that you can determine all the values of the currents. Right? So I hope you have followed it. After indication of this, now we can easily able to solve the problem by using what are the steps we have to carry out. Okay, so what is the first step? So step 1, first we will calculate all the field copper loss. Okay, all the copper loss. Okay, so total copper loss calculation, total copper loss. Now start with the for motor. Okay, what is the armature copper loss? Armature copper loss, so that is nothing but IAM square into RA. What is the IAM value? It is 37, so 37 square multiplied by RA 0.33. when you calculate this you will get the answer as 451.7. 451.7 watts. Okay, similarly calculate the field copper loss. So that is V into I shunt M. So it is 230 multiplied by what is the shunt value of a current. So that is 0.85. So it is 0.85. Okay. So it leads to 195.5. 195.5 watts. Okay. So after this, sum these two currents, add these two values. Okay. So therefore, the total copper loss of motor it is around 451.7 plus 195.5. When you add these two, you will get 647.2 watts. 647.2 watts. This is about the motor. Similarly, we have to calculate for the generator. For generator also, the armature copper loss will be given as IAG square into RA. So it is the IAG value is 30 ampere. So 30 square into 0.33. So it leads to 297 watts. Similarly, for the field copper loss, it is V into I shunt G, that is 230 multiplied by 0.8. So the answer will be 184 watts. So when you sum up these two, okay, so you'll get 481 watts. 481 watts. Okay. So this is what we had completed the step number 1. Next, let's start with the step number 2 to calculate the stray loss. Stray loss is given by the formula. Stray loss, which is denoted as WC, it is given by the formula power input from the supply. So it is V into IL minus the total copper loss. The total copper loss of motor plus the total copper loss of the generator. We have to add now total copper loss of motor and total copper loss of generator. Okay. So what is the value? You can get it V into IL, that is 230 multiplied by the current, the line current. Okay, so the line current, what is the line current from this circuit diagram? Which is the line current? This is the line current. Okay, that is 8.65 ampere. So you have to take that, you have to identify the value of that which current it is, 8.65 minus the sum of those two values. What is that? For the motor we got total copper loss 647.2 plus the total copper loss which we obtained for the generator, it was 481. So you have to add up this. So we get the value as around 861.3 watts. 861.3 watts. Okay, this is WC. Now for per machine means WC divided by 2. So it is 861 divided by 2. So it leads to 430.6. 430.6. See, this value you have to remember. 430.6. This value you have to remember, because that value only we have to take it to determine the efficiency separately for the motor and separately for the generator. Okay. So that value we have to consider. Not the total value. We have to take a half of this value. Okay. Now let's start the last step, step number 3, to determine the efficiency of a motor. So efficiency of motor is given by the input minus losses divided by the input into 100. Okay. So what will be the motor input? Motor input, as I told you, it is given by V into, see here you can observe to this motor what are the input value of a current. See, this is the combination of, this is actually the input value which is entering into this motor. So therefore this current is nothing but sum of the IL and the sum of the current which is coming out from the generator. So I can call that is also a line current which is taken up from the generator side. Okay, so we have to sum these two, this value and this value. So that together is given into the motor input. So that value we have to take it, IL plus ILG. Right, so that is nothing but 230 multiplied by what is this, the addition of these two value of current, 37.85. So 37.85. So when you solve this, okay, so you'll get the value as 870.5. 870.5 watts. Okay, this is about the motor input. And the total losses is nothing but, the total losses is equal to the variable loss plus the constant loss. What is that variable loss? Variable loss means the copper loss. Copper loss of what? Motor, because we are calculating efficiency of motor. Okay, so we have to take the total copper loss of motor, okay, plus WC divided by 2. Okay, so what is the total copper loss we had got? Total copper loss. See, total copper loss we got it as 647.2. 647.2 plus the stray loss for the per machine, it is 430.6. 430.6. Okay, so substitute all these values here. Fine, and determine the efficiency of motor. So we'll get the value around 87.6%. So we'll get the answer as 87.6%. This is about the efficiency of the motor. Right? Similarly, let us determine the efficiency of a generator. Let's move on with the efficiency of generator. Efficiency of generator. The efficiency of generator is given by, output divided by output plus losses. Output divided by output plus losses. Okay. So what is the generator output? Generator output is nothing but V into ILG. Okay, so it is 230 multiplied by, you can see here, observe that what is the current which is given out from the generator. So it is around 29.2 amps. So you do that product of these two values. Okay, so you'll get the answer as 6716 watts. Okay, that is about the generator output. Next, coming to the total losses. The total losses will be the total copper loss of the generator. Total copper loss of a generator plus the stray loss per machine. So what was the total copper loss of a generator? It was nothing but 481. Okay, 481 plus 430.6. So finally we get the efficiency of around 88.04. So just check that, you'll get the efficiency as 88.04%. So this completes the problem based on the efficiency of generator and motor by using the Hopkinson's test. Thank you for watching this video.